Hey there, scholarly gamers, and welcome to the latest episode of PC Building Fundamentals. It's quite funny, when I make these videos, I don't really write a script or anything. It's very much just kind of off the top of my head, and so therefore sometimes I end up waffling on, rambling, and it results in me having to shoot these videos over and over. So hopefully this time I can try to keep it, short but informative at the same time. So we're not quite getting into actually building a PC yet. We're not, going to be getting all in around the hardware because the first step in my mind is, planning, right? Actually figuring out what your use case scenario is. Many years ago, computers, they weren't simple by any means, but there were four main types of computer. Of course, these were the first was the supercomputers, these huge, enormous mainframes that were used for gargantuan computations and whatnot. Then you had your mini computer, which was a smaller type of computer, obviously, but not quite as small as we're accustomed to these days. Then the microcomputer, which again was still quite powerful. And then all the way down to the personal computer, which came in all sorts of different types of variants. But you fast forward to nowadays, and the computing scene, there's a lot more different models that are going around. I mean, in its very, very simplest form, a personal computer was, a computer that was based on x86 architecture. This goes back to the days of the old 286s, the 386s, and so on and so forth. And now we no longer use that nomenclature. That used to be how you quantified the generation of a PC, a 286, a 386, a 486. And by the time we got into the Pentiums, we just kind of threw that away. But most CPUs these days are still based off the x86 architecture, whether they're from Intel or from AMD. Yes, there's other processors out there, those from ARM, some Android-based devices, but for the most part, most personal computers use an x86 architecture of some kind. Now, yes, you have your typical kind of home PC, and of course there's the Apple variants. For the purposes of this series, we're not going to get into Apples. It's not to say that they're bad computers, but by no means, they have very, very good scenarios where it might make more sense for you to use an Apple. But when it comes in terms of actually working on them and upgrading them, Apple computers are not simple by any means because all of the components are tied into vendor IDs. Hence why you have to take your PC, well, not your PC, but your Apple computer to the Geek Squad and have it serviced by a certified Apple technician. So that does us no good. We need to be talking about PCs. But, personal computers, it really used to be a case of there was a personal computer for the home user, and then there were professional computers, and these were called workstations. Now, workstations were quite expensive, and this day and age, they still are very expensive. Workstations would typically have a different class of central processing unit, CPU, on them. For the Intel side of things, these were the Intel Xeons, which are quite more expensive than their consumer counterparts. And same nowadays with AMD, it's the EPYC series of processors, which are also significantly more expensive than your typical desktop Ryzen. Another thing that set the workstation PCs apart was the fact that they tended to use a different type of random access memory, RAM. Usually they would use ECC, which is error correcting code. RAM has errors all the time, just usually you might not notice it. Yes, sometimes your computer may hang or maybe a program will crash, and a lot of times this is due to an error in the RAM. But, errors will happen all the time and you might not even notice it. But in a professional workstation scenario, sometimes these errors can, just throw your computations or anything, completely out the window. Hence why they tend to use ECC RAM. And it's the same with professional workstation motherboards. Usually they can support multiple processors, again, for that more kind of computational power. Keep in mind that workstations are usually for professionals, people that need, absolute perfection when it comes to computation. Even content creators, it used to always be a case of workstation PCs gave them that extra horsepower. And usually a workstation PC will also have a professional grade graphics cards. These are your NVIDIA Quadros, your AMD Frontiers. These cards, and well, now the new NVIDIA Turings are right around the corner. These GPUs are, yes, they're extremely powerful. You can use them for gaming, but that's not what they're designed for. They're designed for advanced machine learning. Again, floating point operations at a level that require accuracy within, thousands of a thousands of a thousands of a thousand, decimal place. So for the average consumer, a workstation PC doesn't make sense. But in the business world, where time equals money, you need that, kind of perfection, so to speak. But again, they are very, very expensive. As time has progressed, we now have this new type of computer on the market, and that, of course, is the gaming PC. Now, I know it's easy to get cynical about the term gaming because, well, usually if anything has gaming in the title, then it's most likely got RGB and it costs more than a similar product that doesn't have gaming in the title. But what's interesting about gaming PCs and gaming components is that they're the consumer alter ego of workstation PCs. Most gaming PCs, yes, are very high-end products, albeit still consumer-grade products. But, there's a lot more horsepower compared to that old beige box that your grandparents used to have kicking around. So gaming PCs have actually now gotten to a point where a lot of professionals will build a gaming PC and possibly substitute, instead of having a gaming video card in there, put one of the professional grade video cards. And there you go. You've got a workstation PC for considerably less money than what it would cost to build a workstation. But, if you are a professional and you need a workstation PC, it probably does make more sense to purchase one pre-built because you're going to get the benefits of on-site service, 24/7 customer support, and then likewise, there's just sometimes components that can work for a gaming PC once you put them all together might not necessarily work perfectly with the software you need as a professional. So these are things to consider. But let's be honest, for the most part, we're talking about gaming PCs, aren't we? Maybe you don't specifically need that PC for gaming, but that's the market you're going to be looking at because they are more affordable and it's more, it's easier to try to figure out what parts to use. But you do need to think about what exactly you're going to be using your PC for and what level of performance you need. For example, if you're going to be playing mostly indie games, or even say kind of, role-playing games that aren't that graphically intense, you know what I mean, the type of kind of isometric, top-down, there's no need for you to spend hundreds and hundreds on a top-of-the-line video card. Likewise, if you're only into, say, a certain type of first-person shooter, it might not make sense to spend a lot of money on a top-of-the-line CPU, because gaming's a strange animal, if we're honest. Yes, I know it's easy to just take the most money you can and throw it at a problem. If you buy the best of everything, the chances are it's going to play whatever you want it to play. And for the most part, that is true. But what if you build a gaming PC and then later find out, hey, I want to stream? Believe it or not all gaming PCs can stream really that well. Because when you get into the realm of streaming, you need more cores and there's other things to consider. We've talked about that before in streaming fundamentals. But then likewise, if you're a content creator and you want to edit videos, you also need to look at different aspects. That's like my current build. It's an older PC. It's a 4th gen i7. And video card wise, a GTX 1060, it does me absolutely fine for 1080p gaming. But then when I got more into video editing, I found that, well, it does the job, albeit a bit slower than I would like. So now for my next build, I'm more focusing on the content creation side. Yes, I still want a PC that's going to be capable of gaming, but I'm going to spend, or I'm going to focus more on things like more RAM. I need more RAM for manipulating videos in the timeline. I need more processing power for rendering. And even that is going to dictate what you buy. Because, for example, if you use Adobe Premiere, there's a really good argument to use an Intel processor, because now they support QuickSync encoding. And once you enable that, you notice your render times, significantly go down. Whereas maybe you're using a different program. Maybe you're like me and use an older version of Vegas, where none of that matters. So I need more cores. So an AMD CPU will make more sense for my use case scenario. But yeah, you need to really kind of figure out what you want to do. And so I wanted to have a quick look actually at PC Building Simulator, because, it's a fantastic game. And it is that. I mean, it's a game, but at the same time, you can do a lot of really, really neat things within it. When it comes to experimenting with configurations, when it comes to, seeing how parts may look. They've got a great library of all sorts of different components, and of course, different levels of performance. So now this isn't really an ideal situation. I mean, we're talking about, I'm using a game, and within this game, I'm using the Synthetic Benchmark 3D Mark. Now, in the real world, 3D Mark is an extremely useful tool, but of course, within the game, it's just kind of giving you, a ballpark idea. But this kind of shows the difference. If you're thinking about solely from a gaming standpoint, the difference that using a different CPU will make. In this first build, and all of these computers, even so the colors are slightly different, are identical. They're all Intels, they're all using an NVIDIA GTX 1080 Ti, they're all using 16 gigabytes of Corsair Dominator RAM, they're all using an M2 SSD. But what we've done differently is on machine 1, we've put in a newest i3 processor, whereas on unit number 2, we've put in an i5, and then on the third PC, we've got an 8700. So if we just have a glance, we can see that, of course, the 3D scores, the overall scores are very, very, they're different between them. But when we look at the individual graphics scores, now this is the i3 system, we can see that the graphics test has a score of 9,110, with FPSs of 59 and 52, but the CPU score is quite low. Now, if we come to the i5, we'll see that the graphics score is identical, but of course the CPU score is higher. And then lastly, if we come to the i7, once again, the GPU score is exactly the same, but the CPU score is significantly higher once again. Now, again, this is not 100% representative of the real world, but it does give you a very good idea. You'll often hear the term bottleneck, and bottleneck is somewhat of a misnomer. Now, yes, you can understand what a bottleneck means, right? Whenever you've, say, if you've got an 8-lane highway, and then all of a sudden it goes down to 4 lanes, traffic is going to slow down, isn't it? Because all of these cars have to now merge from 8 lanes to 4 lanes. So we use this term in the computing world for when a certain component is restricting the performance of other components. Now, in all reality, in the computer world, a bottleneck will always be present. Think about it. If there wasn't a component that was slowing anything down, then hypothetically, a PC could, just keep getting faster and faster and faster until the damn thing melted. So bottlenecks will always be present. But it's interesting to understand what bottlenecks are going to affect you for gaming. Because let's be honest, in this day and age, most games don't really take advantage of more than 4 cores, if you're lucky. So having an all singing, all dancing 8-core, 16-thread processor, if you strictly just want to game, doesn't make a lot of sense. Whereas, if you want this to also be a streaming machine, then okay, yeah, having those extra cores makes sense. Now, yes, in the real world, the top-of-the-line i7 from Intel is still the best CPU for strictly gaming. When you look at frame rates and whatnot, yes, that's going to have the highest marks. But in the real world, you can get away with an i3 for most games. But it depends on several factors. The bottlenecks that can appear will depend on the resolution you play at. And this is because of the amount of stress that is put on different components. If we talk about, say, a top-of-the-line 1080 Ti, yes, it's an expensive video card, but wow, it really, really does perform. Now, at 1080p, one of the lowest kind of mainstream resolutions we use, that video card can just, cut through that like a hot knife through butter, right? I mean, it doesn't put that card under any stress. So what happens in a PC is, because that video card can handle that so easily, it ends up offsetting stress to the CPU. Because let's use CSGO as an example. The video card can quite easily churn out 250, 300 frames per second. And you get to the point where the CPU could possibly actually have a hard time keeping up with the video card. So with a 1080p benchmark, if you took that i3, that card might only be pushing out, say, 200 frames per second. But then when you put in an i5 with that more processing power, it's feeding more information to the video card. So now all of a sudden you see the scores jump up to 300 frames per second. And then likewise, slapping an i7 with its excuse me, 6-core 12 threads plus a really high clock speed, and now all of a sudden you're seeing that benchmark score go in excess of 300, maybe even close to 400. It's quite interesting. Now, yeah, you're not going to see those gains in front of your eyes. It's not going to make much of a difference between 200 and 400. But synthetically, for the benchmark chasers out there, trying to go for records, it makes a heck of a difference. But this is where it gets really, really interesting, because as the resolution goes higher, say if we go to 1440p in that same experiment, with an i3, an i5, an i7, then actually the scores, or the frame, the FPS, kind of gets a lot closer, because more stress is being put on the video card and less on the CPU. Now, yes, 1440p, good chance the video card's still tearing through it, so you're still going to see a noticeable difference. But what gets really, really interesting is if you go to super high resolutions like 4K, and within those different CPUs, you'll see benchmark scores that are very, very similar, or rather, FPS, because it's the video card that the main strain is being put on. And so the difference in frames per second in 4K between an i3, an i5, and i7, a lot of the times will be very, very similar. They'll all be low, depending on the game, probably say in the mid-40s, but there's not going to be as much of a noticeable difference. Now, this does depend on the game. Some games do require, more processing power, especially if they've got advanced physics, a lot of models, character models on screen at once. But it's quite interesting to understand this, where when you're getting into your use case scenario, if you're building a gaming PC, one of the first things you need to consider is, what resolution am I going to play the game at? What kind of monitor will I buy? Now, we'll go into monitors in more detail in a later episode, but right now at the planning stage, that's going to dictate a lot of things, or a lot of purchases for you. If you're only planning on playing on 1080p monitors, then okay, you only need a certain level of video card. Unless we're talking about you want a certain level of performance as well. If you're going to be buying a 1080p panel that has a 240 hertz refresh rate, then yeah, okay, you do need that higher level of performance. But then likewise, if you're buying a 1440p panel that only has, say, a 100 hertz refresh rate, and it's got FreeSync, well, you could maybe go with something totally different. So it's important to consider what you want your PC to do, as that's going to dictate what you buy. There's nothing worse than thinking, right, I'm going to buy the best of everything, but then only to find out that, yes, it excels in some ways, but not in others. It happens all the time, where I see people buying what they think is going to be an all-singing, all-dancing computer, and the harsh reality is, if you try to build something that's going to do everything, it might excel in one aspect, but it's probably going to be kind of okay in the others. So you need to kind of prioritize what you want your PC to do. If it's primarily for streaming, then okay, we've got totally different things to consider. Likewise, depending on whether we're talking about streaming a PC game or a console game. If it's just going to be a gaming machine, then yes, we've got a whole other set of priorities to consider. And likewise, if you just want a monster video editing rig, you know, you're going to be prioritizing totally different components. So it's just keep this in mind. Your use case scenario is going to dictate what you buy and where you spend your money. And in many ways, it's also going to affect what type of case you're going to buy. Now, we're going to go into that in more detail. Hopefully the next episode, we'll just see. It depends how my purchases pan out. But, you know, even that is going to affect what components you buy, because we've got all sorts of different form factors. We've got all sorts of different cooling requirements for different components. So it might sound like a great idea to build a tiny little, you know, box that's going to be a super duper video editing rig, whereas the harsh reality is, no, you could probably build a small gaming rig, but not necessarily, you know, the same would be true for video editing. So that's really just the point of this episode, is to think about what do you need your PC for. Write down what your priorities are. If it's, you know, the resolution, if it's a certain frames per second, if it's even something as simple as you just want it to be quiet. These are all things to consider. Footprint, you know, you have to plan this out. There's nothing worse than just buying a bunch of stuff and trying to make it work. I've always been a big believer in, you know, 80% planning, 20% execution, and it just works well for any of your endeavors. You know, same if you were going to be building a shed in the back garden. What is that shed going to be used for? Do you need to make a really strong foundation? What material are you going to use for it? I know it sounds silly using that, you know, as an analogy, but it's just the way it is. If we're honest, you have to plan these things out. So again, sorry there isn't that much content in this video. There's no real tips and tricks or any kind of secrets. A lot of it is really common sense, but it's common sense that's really important. You want to consider what you're going to be using your PC for before you even pick up that first tool and order your first item. So anyway, that's going to do it for this episode of PC Building Fundamentals. As I say, hopefully next time we'll maybe jump into cases. You know, the plan is to talk about individual components and also go into some of the kind of good practices when it comes to installing different components. It is going to be a long drawn out series because, again, you know, it depends when also I purchase the parts for this new build I'm doing. So just, you know, stay patient. Stay you know, optimistic that you will get something out of the series. It's just when we're starting off, things are a little bit slow, and we need to, you know, really be a bit more kind of talking about, you know, the hypothetical aspects of it, you know, imagining things before we can get into the actual hands-on and the get down and dirty. But anyway, look, thanks for watching. I'll catch you next time on PC Building Fundamentals. And hopefully we'll actually get to building.